Hello and welcome, students. Today, we're going to learn about a really important topic in physics, how to calculate the motion of objects under the influence of gravity. Now, I know this can be a tricky area sometimes, but don't you worry. We're going to learn a clear, step-by-step method today that will help you master it.
So let's have a quick look at our plan for today's session. We'll start with a quick refresher on free fall, and then we'll introduce the main equations we'll be using. After that, we'll cover what I think is the single most important rule, getting the signs right. Then we'll apply everything to two classic problems before we wrap up with a summary and some really helpful tips for your exams.
You know, just think about an apple falling from a tree, or maybe a ball that you throw up in the air. We see things like this happen every single day. But in physics, our goal is to describe them with numbers, to calculate exactly how fast they're moving or how high they will go. By the end of this session, you'll have the exact tools you need to do just that.
Okay, so let's dive right in. Before we can jump into the calculations, we need to be absolutely clear on a few basic ideas. So let's have a quick revision of the concept of free fall. So, what exactly do we mean by free fall? Well, in physics, we say an object is in free fall when the only major force acting on it is the Earth's gravity. Now, it's important to remember that for all the problems we'll solve today, we're going to ignore other things like air resistance. This just helps keep our calculations simple and clear.
Now, as an object falls, what happens to its speed? It increases, right? This change in velocity means there has to be an acceleration. And this specific acceleration, which is caused by Earth's gravity, has a special name. We call it the acceleration due to gravity, and we use the letter g to represent it. And here's the amazing part. Near the Earth's surface, the value of g is more or less constant for all objects. It doesn't matter if they're big or small. Its value is approximately 9.8 meters per second squared. Sometimes, just to make the calculations easier in problems, you might be asked to use the value 10.
So, the fact that g is a constant acceleration is actually very good news for us. It means we can use a standard set of three powerful equations, which you already know as the equations of motion. All we need to do is make one tiny change. We just replace the general acceleration a with our specific acceleration g.
These three equations are going to be our main tools. Let's look at the first one, v equals u plus gt. This equation is perfect when you need to find out how fast an object will be going, that's its final velocity, v, after a certain amount of time t has passed.
Okay, on to our second equation. S equals ut plus half gt squared. This one is super useful when we want to calculate the distance an object has traveled, or more correctly, its displacement s, over a specific time period.
And finally, we have v squared equals u squared plus 2gs. This equation is incredibly helpful because it connects the velocity and the distance directly, without you needing to know anything about the time taken. This can be a real time saver in certain problems.
Now, just knowing these equations is not enough. We have to know how to use them correctly, and for that, we must learn the rules. This, my friends, is the most important step, and it's where students often make mistakes. It's called the sign convention, so let's pay full attention here.
Let's make a simple rule together, and we'll stick to it for all our problems. We will decide that any quantity, like velocity or displacement, that is directed upwards, we'll call that positive, and any quantity that is directed downwards, we'll call that negative. Now, just take a moment and think. Which way does gravity always pull things? That's right, always downwards. So what does that mean for g? It means the acceleration g will always be a negative value in our calculations. This one idea is the real key to solving these problems correctly.
All right, theory is one thing, but let's see how it works in practice. Let's take our first case study and apply these concepts and our new sign rule to an object that is falling straight down. We'll go through a problem together, step by step.
So here's our first problem. A car falls off a ledge and drops to the ground in half a second. To keep it simple, we'll use g as 10. We need to find two things. First, what is its speed just as it hits the ground? And second, how high was the ledge it fell from?
Now, whenever you see a physics problem, it is always a good idea to follow a clear method. We will use these four simple steps that you see on the screen. First, we list all the given values with their correct signs. Second, we identify what we need to find. Third, we choose the right equation for the job. And finally, we just substitute the values and solve. Let's try this now.
Okay, so let's apply our method. Step 1. List what's given, with their signs. The problem says the car falls. Now that's a key word. It means it starts from rest. So its initial velocity, u, is 0. The time t is given as 0.5 seconds. And now for g. Remember our sign convention? Gravity always acts downwards, so g must be negative. We write it as minus 10 meters per second squared. Getting this sign right is the most critical part of the whole problem.
Now we choose our equations and solve. To find the final speed v, the equation v equals u plus gt looks perfect. So let's substitute our values. V equals 0 plus, in brackets, minus 10 times 0.5. This gives us v equals minus 5 meters per second. Now the negative sign just tells us the velocity is in the downward direction, which makes sense. To find the height, we'll use s equals ut plus half gt squared. Substituting again, s equals 0 plus half times minus 10 times 0.5 squared. When you work that out, we get s equals minus 1.25 meters. And again, the negative sign just confirms the displacement is downwards. So the height of the ledge is 1.25 meters.
Excellent. So, now that we've solved a downward motion problem, let's look at the opposite case. What happens when we throw an object straight up into the air?
Let's look at this example. This time, an object is thrown vertically upwards, and it rises to a height of 10 meters. We need to calculate its initial velocity and the time it took to get to the top. Now think, since the displacement s is in the upward direction, what sign should it have? Positive, of course. So we'll take s as plus 10 meters in our calculation.
Now this is a very, very important point that you must always remember. When you throw something up, it goes up, it slows down, and for a tiny, tiny moment at its highest point, it stops before it starts falling back down. So at that highest point, its final velocity v is 0. But let me ask you a question. Is gravity still acting on it at the top? Of course it is. Gravity is always pulling it down. So the acceleration g is still minus 9.8 meters per second squared.
So let's list our values for this problem. We know the final velocity at the very top, v equals 0. We have the displacement, s equals plus 10 meters, and we have the acceleration, g equals negative 9.8. To find the initial velocity, u, the best equation to use is v squared equals u squared plus 2gs, because it connects everything we know. Plugging in the numbers, we can solve for u, and we get 14 meters per second. See? The answer is positive, which makes perfect sense because the initial throw was upwards. Then, to find the time, we can use v equals u plus gt, and that gives us the time taken to reach the top, which is 1.43 seconds.
Very good. We have now covered both cases of motion under gravity. So let's quickly summarize everything we have learned to make sure you remember it well, especially for your exams.
This table gives a fantastic summary of the key differences. For an object that is dropped, its initial velocity, u, is 0. But for an object thrown upwards, its final velocity, v, is 0, only at its highest point. But look carefully at the acceleration. In both cases, g is always acting downwards, so we must always treat it as negative in our calculations according to the rule we set.
And finally, here are some very practical tips for your exams. Before you even start solving, on your answer sheet, write down your sign convention. Upward is positive, downward is negative. Then carefully list all the given numbers with their correct signs. Always remember that g is downwards, so it's negative. And never, ever forget that at the highest point of a journey, the velocity is 0, but the acceleration is still g. If you follow these simple steps, you will avoid common mistakes and score full marks. Keep practicing, and you will do very well.